Hello students, welcome to IIT PAL Mathematics Problem Solving Session. This is lecture number 2 and our topic is matrices and determinant. In today's lecture, I will solve some more problems related with matrices and determinant. The required background for these problems is already being given in the first lecture. Okay, so let's start with question number 1. Question: okay, if the adjoint of a 3 cross 3 matrix P is 1 4 4 2 1 7 1 1 3, then what are the possible values of the determinant of B? Okay, so this is the question. So let's solve this problem. So answer. Okay, so as we know that for an n cross n matrix A, determinant of adjoint A is equals to the determinant A to the power n minus 1. Okay, and we have adjoint P is given as 1 4 4 2 1 7 1 1 3. So this is the adjoint of P, right? Okay, so this is so. Then what will be the determinant of this adjoint of P? So determinant of adjoint of P is given by 1 into 3 minus 7. Okay, then minus 4 into 2 into 3, 6 minus 7, plus 4 times 2 minus 1. Okay, so this is nothing but, so this is minus 4, this is plus 4, and then this is plus 4, and this is equals to 4. So given n is equals to 3, determinant of adjoint of P is equals to determinant of A of whole square. This implies and this is the P. Okay, this is determinant P. This implies determinant P whole square is equals to 4, implies determinant of P is equals to plus minus 2. So let me just check in the first slide. Okay, this I have written it for the any general A matrix, this formula. All right. Okay, so this is the final answer. So determinant of P has two values, plus and minus 2. Let's solve another question. Okay, so for 3 cross 3 matrices M and N, show that the first part is N transpose M N is symmetric or skew symmetric according AM is symmetric or skew symmetric. Okay, let's write this in another line, or skew symmetric. So this is the part 1. So what it says that N transpose, we need to show that N transpose Mn is symmetric. If M is symmetric, it is skew symmetric. If M is skew symmetric. Second part is M into N minus N into M is skew symmetric for all symmetric matrices M and N. Okay, so how to solve this problem? Okay, so let's solve it. Answer. So let's solve the first part. Okay, so first suppose M is a symmetric matrix. This implies M transpose is equals to M. Now we need to show that N transpose Mn is symmetric matrix. So let's take its transpose. That means we need to show that the transpose of this matrix is itself. So okay, so let's make the pair. For example, the first one is the N transpose, we take it as a one matrix. M into N, we take it as another matrix, and it's transpose, and this is nothing but Mn transpose N transpose of transpose, because we know that AB transpose is nothing but B transpose into A transpose. So now again we can apply the transpose formula in this product of matrix. So this is nothing but N transpose M transpose and N, and because M transpose is M, so this is nothing but N transpose M N. So what did we show? We showed that N transpose Mn transpose is nothing but N transpose Mn. So this implies that N transpose M into N is symmetric matrix. is a symmetric matrix. Okay, so now if we suppose that M is skew symmetric, okay, so another part of the part 1 itself, let M be a skew symmetric. This implies M transpose is equals to minus M. Okay, then again we do the same thing. We take the N transpose Mn and we take its transpose, and we know that from in the previous slide this is nothing but N transpose M transpose N. Now in place of M transpose we write it as a minus M, so this is nothing but minus N transpose M N. So this implies N transpose M N is a skew symmetric matrix. Skew symmetric matrix. Sorry, matrix. Okay, so this is how we prove the first part. Now let's prove the second part. Here we need to show that if M and N are symmetric matrices, then we need to show that Mn minus Nm is skew symmetric. Okay, so let M and N be symmetric matrices. This implies M transpose is M and N transpose is N. Okay, so now let's take this matrix Mn minus Nm and then take the transpose. As we know that this A minus B transpose is nothing but A transpose minus B transpose, so this is nothing but Mn transpose minus transpose. This is nothing but N transpose M transpose. Here the product formula we use, and this is nothing but M transpose N transpose, and this is nothing but N transpose is N, so it's N. M transpose is M, this is M minus M N. So this is nothing but minus, we take a common, M N minus N M. So this implies what? So Mn minus Nm transpose is the negative of the Mn minus Nm. So this implies Mn minus Nm is a skew symmetric matrix. Okay, so this is how we prove both the parts. Okay, so let's solve another problem. Question: let x and y be two arbitrary three cross three non-zero skew symmetric matrices and be an arbitrary 3x3 non-zero symmetric matrix, then show that y cube z to the power 4 minus z to the power 4 y cube is a symmetric matrix. B part x to the power 44 plus y to the power 44 is a symmetric matrix. Part C, x to the power 4 z cube minus z cube x to the power 4 is a skew symmetric. Part D, x to the power 23 plus y to the power 23 is a skew symmetric matrix. Let me just erase this. Okay, so this is the problem. So let's solve it. Okay, so it is given that x transpose is equals to minus x, y transpose is equals to minus y, and z transpose is equals to z, because x and y are skew symmetric matrices and z is a symmetric matrix. Okay, so let's see what can we say about x to the power n transpose, what y to the power n transpose, the z to the power n transpose for any natural number n, okay. So let's see, x to the power n transpose is nothing but you multiply x by n times transpose, and this is n times. Okay, so let's use that formula, the product of a transpose, x transpose into x transpose into x transpose, and this is nothing but minus x okay. So let's say that this is nothing but x transpose to the power n, and this is nothing but minus x to the power n. So this is nothing but minus 1 to the power n x to the power n. So this is the relation we have. That means x to the power n transpose is equals to minus 1 to the power n x to the power n. So this means x transpose, this means x to the power n transpose will be equals to x to the power n if n is even, and this is minus x to the power n if n is odd. So the same thing is true for y, because y is also skew symmetric. So y to the power n transpose is equals to y to the power n if n is even. This is minus y to the power n if n is odd. So now let's see what we can say about z to the power n transpose. So this is nothing but z multiplied by z n times, okay, so this is nothing but z transpose multiplied by z transpose, and this is nothing but z transpose to the power n, and z transpose is z, so this is nothing but z to the power n. So we have z to the power n transpose is equals to z to the power n for all n. Okay, so let's use these relation in proving all these four parts. So let's go to the part A. Okay, so it says that y, this is the matrix we need to investigate, y cube z4 minus z4 y cube. Okay, so let's take transpose. This is nothing but y cube z to the power 4 transpose minus z to the power 4 y cube transpose. Okay, so now again the product one, this is nothing but z to the power 4 transpose y cube to the power y cube transpose minus y cube transpose z4 transpose, because z was the symmetric matrix, so any power of z and its transpose will give the same z to the power 4. Okay, here 3 is an odd number, so y cube transpose will be nothing but minus y cube. This is minus y cube, and this is z4. So this is nothing but, so this will be plus nothing but y cube z4 minus z4 y cube. All right, so this means this is same as this, right? So that means this matrix is symmetric matrix. This implies y cube z4 minus z4 y cube is a symmetric matrix. Is a symmetric matrix. Okay, so let's go to the another part, which is part B. So here we need to investigate this x to the power 44 plus y to the power 44. So let's take a transpose. So this is nothing but equals to x to the power 44 transpose plus y to the power 44 transpose. Okay, so because 44 is a even number, so that means this is nothing but x to the power 44, and this is y to the power 44. This implies x to the power 44 plus y to the power 44 is a symmetric matrix. Okay, so now go to the C part, which is also similar, x to the power 4 z cube minus z cube x to the power 4. So let's check this. Take transpose, and this is nothing but x to the power 4 z cube transpose minus z cube x to the power 4 transpose. This is equals to z cube transpose x4 transpose minus x4 transpose z cube. Alright, so this is nothing but z cube, this is nothing but x4 minus x4 to the power 4 z cube, and this is nothing but the minus of x to the power 4 z cube minus z cube power 4. So this means this matrix, this implies that x to the power 4 z cube minus z cube x to the power 4 is a skew symmetric. Matrix. Okay, so let's go to the last part D, which is also simple. It is x to the power 23 plus y to the power 23. So if we take a transpose, because x and y both has the odd power, so this is nothing but x to the power 23 transpose plus y to the power 23 transpose, and this is nothing but minus x to the power 23 minus y to the power 23. So which is again minus times x to the power 23 plus y to the power 23. So this implies that x to the power 23 plus y to the power 23 is a skew symmetric matrix. Okay, so this is it. So these type of problems you can always solve just by looking at this power of x and y, whether it is a odd power or even power. We can make a use of that to solve these type of problems. Okay, so let's solve another problem. Let k be a positive real number okay, and let A be a matrix, 3 cross 3 matrix defined as k minus 1, 2 root k, 2 root k. Second row is 2 root k, 1 minus 2k minus 2 root k, 2k minus 1. Okay, and there is another matrix B, which is defined as 0, 2k minus 1 root k, 1 minus 2k, 0, 2 root k. Third row is minus root k minus 2 root k, 0. Okay, if determinant of adjoint of A plus determinant of adjoint of B is equals to 10 to the power 6. Then what is the value of square bracket K, where square bracket K denotes the largest integer less than or equal to K. Okay, so the matrices A and B are given, and there is a relation given, and we need to find the value of square root of K. So let's solve this problem. Okay, so first let's calculate the determinant of A. Okay, so what will be the determinant of A? Okay, so is let me just write it down: 2k minus 1, 2 root k, 2 root k, 2 root k, 1 minus 2k minus 2 root k, 2k minus 1. So let's expand this determinant from first row. Okay, this is equals to 2k minus 1 multiplied by 1 minus 1, so minus 1 plus 4k square. Okay, minus 2 root k. Then we find the determinant of the submatrix, which is minus 2 root k and minus 4 k root k. Okay, plus 2 times root k into 4 times k root k plus 2 times root k. Okay, so let's open this. Okay, so 2k minus 1 multiplied by minus 1, it's 1 minus 2k plus 8k cube minus 4k square plus 4k plus 8k square. Okay, plus 8k square plus 4k. Okay, so this is equals to 8k cube. Okay, then in k square it's 16 minus 4, it's 12 plus 12k square. Okay, and then k, what is the 4 4 8 minus 2 plus 6k plus 1. Okay, so this is the value of determinant A. Okay, since k is greater than or equals to 0, this implies, in fact, rather than it's a positive. So okay, let me just k is strictly greater than 0, this implies determinant of A is strictly greater than 0. Alright, okay. So now let's calculate the determinant of B. Okay, so this is nothing but if we expand from the first row. All right, okay, so let me just write the determinant for you. 0 to k minus 1 root k, 1 minus 2k, 0 to root k minus root k minus 2 root k 0. All right, so yeah, so if you expand from the first row, then first entry is 0, then minus 2k minus 1 multiplied by 2 times k, all right, plus root k, then you multiply with the minus 2 root k plus 4 k root k. All right, so let's expand this. So this is nothing but minus 4k square plus 2k minus 2k plus 4k square. All right, so this is nothing but 0. So the determinant of B is 0. All right, so yeah, so we have a relation which is given. What is that? This is nothing but determinant of adjoint of A plus determinant of adjoint of B is equals to 10 to the power 6. So we know the relation between determinant of adjoint A in terms of determinant A. Given A is a 3 cross 3 matrix, so determinant of adjoint A is nothing but determinant A square. So this is nothing but determinant of A square plus determinant of B square. This is equals to 10 to the power 6. So determinant B is 0. So this is nothing but determinant of A square is equals to 10 to the power 6. Given determinant A is greater than 0, this implies determinant of A is equals to 10 to the power 3. Okay, so now let's write the expression of determinant A which we calculated, which was nothing but 8k cube plus 12k square plus 6k plus 1. This is equals to 1000. So this implies 8k cube plus 12k square plus 6k minus 999 is equals to 0. So basically we need to find the root of this. Okay, so which may be little hard to find. So let's denote this expression on the left hand side by pk. Pk is equals to 8k cube plus 12k square plus 6k minus. Okay, so let's check this value for different value of k. Okay, so let's, okay, so yeah, sorry for that. Yeah, so p1, what is the p1 value? So pk, we know, so p1 is nothing but 8 plus 12 plus 6 minus 999. This is definitely less than 0. So what is P2? So P2 is nothing but 8k cube, so 64 plus, let me just see what is pk. 12 into 4 plus 6 into 2 minus 999. So this is also definitely less than 0. What about P3? P3 is 8 into 27 plus 12 into 9 plus 6 into 3 is 18 minus 999, and this is also turn out to be less than 0 if you just calculate it, because yeah, definitely this number is less than 999. Okay, so what about the P4? P4 is 8 into 64 plus 12 into 16 plus 6 into 4 is 24 minus 999. So let's calculate what is this. 512 plus 23192 plus 24 minus 999. So what is this? Roughly this is 700 something, which is definitely less than 999. So this is also less than 0. Okay, so let's see what is P5. P5 is 8 into 125 plus 12 into 25 plus 6530 minus 999. So this is nothing but 1000 plus 300 plus 30 minus 999. This is greater than 0. So basically between 4 and 5, after 4 it changes the sign. This pk, that polynomial, changes the sign. So this implies that there will be a 0, pk will be 0 for some k lies between 5 and 4. Okay, so this means what? Because this implies k, which is the largest integer, less than or equals to k, so which will be nothing but 4. Okay, because there is a 0 which lies between 4 and 5. Okay, so this is the final answer. Okay, so let's solve another problem. Question: let P be a 3 cross 3 matrix given by 3 minus 1 minus 2 2 0 alpha 3 minus 5 0. So this is a 3 cross 3 matrix where alpha belongs to some real number. Suppose Q be another matrix such that P into Q is equals to K times I, where K belongs to R, K not equals to 0, and I is 3 cross 3 identity matrix. I is the identity matrix. Okay, so if Q of 2 3 is equals to minus k by 8 and determinant of Q is equals to k square by 2, then show that part A is determinant of P adjoint Q is equals to 2 to the power 9, and part B is 4 alpha minus k plus 8 is equals to 0. So given all this information, we need to prove this. Okay, so certainly we need to find this value of alpha and k, and so let's see how do we solve this problem. Okay, answer. So it is given that P into Q is nothing but K times identity matrix. So if we take determinant on both sides, we get determinant of K times I, and this, since I is a 3 cross 3 matrix, so this is nothing but K cube, and determinant of I, which is equals to 1, and this is equals to K cube. And because K is not 0, this implies this is not equals to 0, because K is not equals to 0. So we have determinant of P into, we can apply this product formula of determinant Q not equals to 0. So from here we observe that determinant of P is not equals to 0, and determinant of Q is also not equals to 0. Okay, so let's see what is a P matrix. So P matrix, which is given, is 3 minus 1 minus 2, 2 0 alpha, 3 minus 5 and 0. So if you calculate the determinant of P, this is nothing but okay, so let's take the third column, because there is 1 0, so let's expand from there. So this is nothing but minus 2 times, okay, this is minus 10, and this is this will be 3 plus 2 5, so this is minus alpha times minus 15 plus 3, so this is nothing but we get 12 alpha plus 20. Okay, given determinant P is not 0, this implies that 12 alpha plus 20 is not equals to 0, because determinant of P is not equals to 0. Okay, so now again we go back to this relation, P into Q is equals to K times I. This implies that, as we did in the beginning, determinant Q is nothing but K cube. Alright, so this implies that determinant of Q is nothing but K cube divided by determinant P, which is nothing but 12 alpha plus 20. Alright, Okay, so determinant Q we know now. Okay, so now again from this relation P Q is equals to K times I, we have, you can multiply P inverse on both sides. So because determinant P is not 0, so P inverse exists. This implies that Q is nothing but K times P inverse. So to calculate the P inverse, we should know what is the adjoint of P. So adjoint of P, so this is nothing but K times adjoint of P divided by determinant P. So let's calculate adjoint of P. So adjoint of P is easy to calculate. It is nothing but the transpose of cofactor matrix. So let's calculate it. Okay, so first entry will be 5 alpha, and then it's 3 alpha. This is minus 10, this is 10, this is 6, this is 12, this is minus alpha, this is minus 3 alpha plus 4, and this is 2. All right, so this is easy to calculate. So now let's see what is Q. Q is nothing but K times divided by determinant P, which is nothing but 12 alpha plus 20, and adjoint P, which is nothing but the same matrix, 5 alpha 10 minus alpha 3 alpha 6 minus 3 alpha plus 4. This is minus 10, 12, and 2. Okay, so this is the Q matrix, and given we know that Q23 is minus K by 8. So let's see what is Q23. Q23 will be the 2, 3 entry of this matrix. So okay, let's see. Given Q23 is nothing but minus K by 8, so this implies this is nothing but minus 3 alpha plus 4 times K divided by 12 alpha plus 20. This is nothing but minus K by 8. So because given K is non-zero, we can cancel on both sides. We have minus this K, and K will be cancelled out, minus will be cancelled out, so we'll get 3 alpha plus 4 divided by 12 alpha plus 20 is equals to 1 by 8. This is nothing but 24 alpha plus 32 is equals to 12 alpha plus 20. So this is nothing but 12 alpha is equals to minus 12. Alright, this implies that alpha is equals to minus 1. So we obtained the value of alpha, which is nothing but minus 1. Alright, okay, so let's use some more relations to find out the value of K. Okay, so another relation we have is determinant of Q is given as a K square by 2. Alright, so what is the determinant of Q? We know that it is, we calculated in the beginning, K cube divided by 12 alpha plus 20. This is equals to K square by 2. Again, K is not 0, so we can cancel on K square from both sides. So K square is gone, the 3 will be gone. So this is nothing but 2 times K is equals to 12 alpha is minus 1 plus 20. So this implies that 2K minus this is 8, 20 minus 12. This implies that K is 4, implies that K is equals to 4. Okay, so we know this, that K is 4, alpha is minus 1, then the part B we can just verify that 4 alpha minus k plus 8, this is nothing but 4 into minus 1, this is minus 4 plus 8, this is nothing but 0. Alright, so the part B is done. Okay, so let's go to part 1. Okay, so the part A is that we need to find the value of determinant of P adjoint of Q. Alright, so this is nothing but, we first use the determinant. Product of the determinant is nothing but determinant of product of two matrices is nothing but product of the determinant P, and to determinant of adjoint of Q, and determinant of P is nothing but 12 alpha plus 20, and this is nothing but determinant of adjoint Q is nothing but determinant of Q whole square, because Q is also 3 cross 3 matrix. Okay, so what is this? 20, and determinant Q was k cube divided by 12 alpha plus 20 whole square, so this is nothing but k to the power 6 divided by 12 alpha plus 20, and alpha is minus 1, so here k is 4, so 4 to the power 6, and this is 12 alpha plus 20 is nothing but 8, so this is nothing but 2 to the power 12, here 2 to the power 3, and this is nothing but 2 to the power 9. So we get determinant of P into adjoint of Q is nothing but 2 to the power 9. So this is what we had to prove. Okay, so yeah, so that's it. So this was the solution of this question. We verified both the parts. Okay students, so I'll stop here now. Thank you for attending this session. I will solve some more interesting problems on matrices and determinant in the next lecture. Thank you.